Okay, in this video, we're going to do all the problems for Chapter 11 that are on the review for the final exam. So the first one is talking about circumference and arc length. So they want you to find the arc length of PQ in feet, and they want you to leave your answer in pi. So here's PQ. We want that length in feet. So what I need to remember, and you have this formula in the back of this packet, but this is the setup. In the denominator, you have the degrees in a circle, and then on top of that, in the numerator, you have the degrees in the given arc. Remember, it's the same as the degrees in the central angle. Okay, then because we're going over looking for length, we're going to put at the denominator of the first fraction the circumference. So circumference equals 2 pi r. You also will be given that formula. The r is 9, so 9 times 2 is 18, and then you bring the pi along. That's how you want to write that. That's the circumference of the whole circle. So both of these bottom numbers pertain to the entire circle. Then in the numerator is going to be the circumference, or the sector, the length of the arc. Okay, the length of the arc. Okay, so this is what we have. Notice that there are proportions. So there's a relationship between the length of the arc and the circumference of the circle, and the degrees in the central angle, and the degrees in the whole circle. We're going to take advantage of that relationship. Okay, you're going to do your cross products. Now, if you want to reduce things first, you can. But I'm just going to go ahead and multiply. So I'm going to say 60 times 18. And that's going to give me, so I did 60 times 18 pi, and I'm going to get 1080, and you bring the pi along. Okay, don't use the pi key. That's going to equal 360 times the length of the arc. So how do we get the arc by itself? You divide by the 360, divide by the 360. In my calculator, I say 1080 divided by 360. That's going to give me 30 pi. Now I need my units. My units were in feet, so I'm still in feet, and that is the length of the arc. Okay, let's highlight that, and then we're good. Okay, our next question asks us instead to focus on area. They say find the area of the shaded sector, and they also want us to leave your answer in pi. Okay, now we're dealing with area. The equation is very similar to what we just did, but let's go over the differences. You're still going to take the arc that you're given, that degree measurement, and put it over the full circle. That's the proportion that I need here. Then instead of doing circumference, I'm now going to do area. And the area of the circle is pi r squared. So take your 18 and square it, and you should be getting 324. And then you're going to add pi at the end. So 324 pi is the area of my circle. Then this is going to give me the area of the sector. So I'll say area gray. Okay? So now do your cross products. So that's this times this. So 324 times 130. That's going to be 42120, and then bring the pi along. That's going to equal, now go the other way, 360 times the gray. Okay, I want to get the gray area by itself. Divide both sides by 360. So take your 42120, divide that by 360. And that's going to give you 117. The pi comes along, and then you want your units. They're in meters, and since we're in area, it'll be meters squared. Okay, so here's your answer for that area. Okay, the next section is 11.5, exploring solids. So we're going to take advantage of Euler's rule. So the pink is called a polyhedron, and they want us to figure out the number of faces, the vertices, and the edges. So this is a tetrahedron, which means it has 4 faces on top and 4 faces on bottom. So the whole thing is an octahedron. So I see that I have 4 faces on top in the light pink and 4 in the dark pink. So that gives me a total of 8 faces. So these pieces right here are called faces. Then the pointy sections, where more than one face combines or intersects, are being identified by these dots. So I have 1, 2, 3, 4, 5, and one more makes 6. So I have 6 vertices. Now I know by Euler's rule that face plus vertice equals edge plus 2. Sometimes I find the edges hard to count. So, for example, this is an edge. So here's 1, and then inside I can't really see them. 2, 3, and so on. 4, here's 5, 6. Okay, so I can keep going. 7, 8, 9, 10, 11, 12. Okay, let's say I'm not so confident about counting those. Can't I use Euler's rule and say, okay, 8 plus 6 is 14. So therefore, the edges have to be 2 less than 14. They have to be 12, which is the number that I just calculated for edges, so I'm good to go. Okay, so you can either prove Euler's rule after you find your edges, or if you're confident with what you've discovered so far in terms of face numbers and vertices numbers, you can just use Euler's rule to find the missing edges. Okay, either way, it works very well. Okay, we have 2 more sections. They both deal with volume. Okay, so the first section is 11.6, and this is volume of prisms. This is a prism, and it has straight edges, so it's a polyhedron, and it has, parallel surfaces, parallel to the bottom. Now, a cylinder has parallel surfaces also, but it's not a polyhedron because it has circular edges. But both of these have volume equations that are represented the same way. Volume equals capital B, which is the area of the base times the height. Okay, so let's say that the bottom of this is going to be my base. Okay, so this bottom is my base. So get the area of the bottom by saying length times width. So that's going to be 32 times 91. That makes 35 the height. Multiply those 3 numbers together. You get 32 times 91 times 35. And I'm getting 920. Okay, now I need units. Each of these lengths, widths, and heights are in centimeters. That means since you multiplied centimeter times centimeter times centimeter, you have cubic centimeters. Volume is a cubic measurement. You're going to have your units raised to the power of 3. Okay, let's do the next one for the cylinder. So this is the cylinder, curved edges, parallel bases. The volume equation is still capital B, which is area of the base, times the height. But the area of your base is a circle. Area of a circle is pi r squared. They gave us a diameter. If the diameter is 12, the radius equals 6. So therefore, the volume of the cylinder is going to be pi r squared, which is 6 times 6, which is 36. You report it 36 and put the pi at the end, times the height of 9 centimeters. They want you to keep your answer in pi. So say 9 times 36. That gives you 324 pi. And once again, your units are cubic and they're centimeters, so it's centimeters cubed. Okay, 2 more problems. We have a pyramid. This is our pyramid. Okay, so this is the pyramid. And we have a cone. Okay, the pyramid's going to be done first. They both have the exact same equation because they both come to a point. So therefore, when I say volume is 1/3 capital B times the height, remember the capital B is the area of your base. Since the base of the pyramid is a square, it's 12 by 12, area of the base is length times width, which is 12 times 12, which is 144. And then the height is listed right over here at 15 feet. Okay, so you have no pi in your answer this time, right? Because you don't have any circular shapes in a pyramid. So let's multiply those 3 numbers together. First, I took 144 times 15, and then I divided that by 3. And I'm getting 720, and I have feet for units this time, and once again, they are cubed. So I can say I have 720 feet cubed in volume, or I can say I have 720 cubic feet. Either way, it's correct. But don't forget your units. Okay, next one is the cone, and this is the last one. So what do I know? I know volume equals 1/3 capital B times H. So once again, the capital B is the area of the base, and this time the base is a circle. So area of a circle is pi r squared. The r is 5. 5 squared is 25. So you will report the capital B as 25 pi. The height is the 12. Ignore the 13. That is not the height. This is extra information. Multiply those 3 terms together. So I have 25 times 12, and then I divided that by 3, and I'm getting 100 pi. They say leave my answer in pi, and my units this time were inches, so they're going to be cubic inches. Okay, and that finishes this video.